Okay, so now we're looking at this video right here. Which of the following transformation is not part of the similarity transformation shown below? Okay, so looking at this one right here, this is a reflection. So first off, I forgot to say, we're starting at this triangle right here. Notice how there's no primes, it's just triangle ABC. So we're starting at this triangle right here. I know I'm reflecting to get to triangle A prime, B prime, C prime. And this is over x equals 1. All right, so it's asking me which of the following transformation is not part of the similarity transformation shown below? Well, I can eliminate C. All right. So we're just doing similarity stuff on a coordinate plane. Next, I can say, well, I can tell, even though this triangle is smaller, I can tell I'm going to be reflecting down here. And ultimately, I would get this triangle before I dilated it. This is the x-axis. So when I reflect over the x-axis, we're going to be using coordinate notation now. We used English in the first one. Now we're just using mathematical coordinate notation. Some random point x, y goes to x, negative y, which is exactly what's described in A, so I can eliminate that. Alright, so not to get too complicated, but this is a composition. This is saying, notice how ultimately I'm going to be getting bigger by a scale factor of 2. So I'm actually doing that one as well. I can eliminate this one right here. This is reflection over y-axis. Because notice how the y coordinate is staying the same, x changes. I never did that, so that's the one I did not do. Cool. All right, cruising right along. The scale factor of corresponding sides of two similar triangles is 2 over 3. Which of the following corresponding parts of these two similar triangles does not have the same scale factor? All right, so perimeters, we already talked about it. It's going to have the same scale factor. Altitudes is a part. It's going to have the same scale factor. Medians are going to have the same scale factor. Angle measures are always just congruent. So D. All right. Sides proportional. All right. Sides proportional. Angles congruent. Angles are not going to be proportional. All right. Chaos would happen if that was true. An NBA court is a rectangle that is 94 feet by 50 feet. A high school court is a rectangle that is 84 feet by 50 feet. Are the two rectangles similar? I don't have to do any calculations. I know the answer is no. Why? These two smaller sides are the same. All right, so the scale factor there is 1. The longer sides, 84 and 84, well, that's not 84 and 94, those aren't equal. This scale factor is not equal to 1. So an NBA court is actually a little bit longer than a high school basketball court. They're not similar. All right. A high definition HD TV has side ratios of 16 to 9. All right, 16 to 9. So that means I can write it as a fraction like this. Non-HD TVs have a side ratio of 4 to 3. So if you guys like watch old cartoons or old TV shows, you notice they have the black bars on the side. That's because TVs used to be a little bit more squarish. Now they're very rectangular. All right. So the fact that I just talked about the black bars show that the pictures don't fit properly within it. We can see this says the decimal is 1.8. This as a decimal is 1.3. Notice how they're not the same proportion. All right, so TV pictures are actually a little more stretched out horizontally now. Little fun fact of the day. All right, so no, they're not similar. So next time you're watching TV, you're watching Disney Plus, Hulu, Netflix, whatever it may be, you guys can think about this stuff. 2 more problems and then we're done. Which of the following statements A through D is false if these two polygons are similar? All right, the scale factor is 3 over 2. So let's pick some corresponding sides again. Complete chaos going on with these pictures, all right? Which corresponds to what? I'm not even really sure. What's very powerful, though, is I can look at this similarity statement right here. A, B, so like A, B, let me do AE actually, because I know that side length. AE, the two last sides, and QP, the two last letters, those correspond. It's saying that they're similar, so I know this is going to be true for all of them. The scale factor is going to be 3/2. So it's saying which one's false, not A. CD equals 21. Well, let's see. MN and CD, those letters match up, so those are going to correspond. So again, I can use this proportion up here, CD over 14 equals 3/2. I'm just using this proportion. I already know that's true. If I do the calculations, I'm going to get 21. I did the calculations in my head. You guys can cross multiply and solve if you want, but I can eliminate that. NP is 6. So NP corresponds to DE. And again, we could set up a proportion, but ultimately, yes, we would get 6. The perimeter of QLMNP is 48. So let's see. So we need one more sides. We need LQ. LQ corresponds to AB. Oh, almost had a brain fart. We don't even have to calculate that. Why? I almost forgot about these tick marks right here. Silly me. Alright, so let's just calculate that really fast. 10 plus 10 plus 6 plus 14 plus 8. Boom, it's 48. The perimeter of that was 48. So this was a trick question. All the statements were true. Alright, we were forced to do a lot of math. We were tricked into it. Alright. Market says that if you add 2 units to the dimensions of a rectangle, you would create a similar triangle. Kayla says that isn't correct because you wouldn't have the same scale factor. Alright. So, this one's question's up to interpretation. Or not really, but let me just... Okay, so we have some rectangle. Let's just say this, we'll just make up a side. That's 2, that's 8. Now we're just going to add 2 dimensions in both sides. So 2 and 2. So this new triangle will have 4 and 8. So notice how this side doubled. We went from 2 to 4. Alright? We went from 2 here to a total of 4. Well, if that's the case, this 8 here would have to double to 16, but we only added 2 side. That's not. This is false. All right, it only went all the way to 10. So who's right? Kayla's right. All right. Well, let me read. Technically, neither's right. Alright, because why? Well, what if we had a rectangle with 2 and 2? Alright, this is actually a square, but a square is a rectangle. If you doubled it, yes, they would still be similar, because then you'd have 4 and 4. So Kayla's right almost every single time except for a specific case like this. Or Kayla's right unless it's a square. Marcus is right if it has to be a square. So this is actually a really complicated problem. So technically neither are right because there's instances where they're both can be right. Alright, so that's it for these notes. I hope you enjoyed them.